Hello everyone, we will start a new topic today. So, till now in this course we have discussed the testing of functional textiles. In testing of technical textiles we have discussed testing of fiber reinforced composite materials, then testing of filter fabrics. After that we have discussed testing methods of geotextiles, and in last class we have discussed testing of ballistic protective clothing. Today we will discuss another area of technical textiles, that is testing methods of UV radiation protective textiles. That is, UV radiation protective textiles are gradually becoming more and more popular, so that we can protect ourselves from UV radiation. So, first we will try to understand what are UV radiation and what are the factors of fabric which will affect the UV radiation protective performance of textiles. So, if you see total spectrum of electromagnetic radiations starting from radio wave to gamma ray. So, gradually the wavelength reduces. So, for gamma ray it is very low, whereas in radio wave it is as high as say 1 meter or maybe more. But our area of discussion here is ultraviolet ray, which affect the human body adversely. So, these are the wavelengths. So, radio wave is more than 10 to the power 9 Armstrong, whereas ultraviolet ray it is around between 10 to 4000 Armstrong. So, before UV ray, if we see here, just before ultraviolet ray there is visible light spectrum. So, the visible light part of the spectrum is divided into different subsections based on color, with red at the longest wavelength and violet at the short wavelength zone. And if we cross the violet, then the ultraviolet UV ray will come, which actually affect our human body. So, ultraviolet radiation it is an electromagnetic wave. The wavelength range is from 10 nanometer to 400 nanometer. Within this range it works, and it has got 4 subdivisions also. It is classified in 4 subgroups. So, starting from UVD, then UVC, UVB, UVA, UVD being the least wavelength, and ultraviolet A is the longest wavelength or of 400 nanometer. We will see the effects of this wavelength on our human body. The energy ranges from 3 electron volt to 12.4 electron volt. Now, UV ray can be classified in two ways. So, this radiation as per the biologist, it can be classified as UVA, UVB, UVC and UVD depending on the effect on our biological species, and according to physicists this can be subdivided in different ways like near UV, middle UV, vacuum UV, like that. So, UVD, the range is between 10 nanometer to 100 nanometer, that is the wavelength range. UVC 100 nanometer to 280 nanometer, UVB 280 to 315 nanometer, UVA 315 to 400 nanometer. So, effectively we will see that UVC and UVD, they normally get absorbed by the ozone layer, whereas the UV ray with higher wavelength get penetrated through the ozone layer, and effectively UVA with higher wavelength in this spectrum does not get absorbed by ozone layer, it enters into a earth surface. So, if we see this table, UVA, the wavelength range is from 315 to 400 nanometer with energy 3.1 to 3.94 electron volt, that energy is less here although, but they are longer wavelength, black light, they are not absorbed by the ozone layer. So, that is the cause of worry. So, we have to protect ourselves, although the energy is least here. So, UVB with energy range 3.94 to 4.43, they are medium wave, mostly they are absorbed, but partially they penetrate through ozone layer. UVC and UVD, they are short wave, they completely absorbed by ozone layer and the atmosphere. Nearly 100% of this UVC or UVD get absorbed by this ozone layer in the atmosphere. Similarly, if we see the other UV ray, depending on their wavelength, they get absorbed. This picture shows that UVA mostly they are transmitted through the ozone layer, UVB they are 95% of them are absorbed, 5% they penetrate, UVA 95% they penetrate and only 5% get absorbed, and UVC almost 100% are absorbed. So, this picture also shows here. So, how they are getting absorbed and penetrated. So, why do we need UV protection? So, if we see UV protection is extremely important, because this UV ray affects the total ecosystem. total all this, not only human, but plant, the environment, other materials and aquatic ecosystem, everything gets affected. As far as human effect is concerned, their immune system suppression is there, skin cancer is very common, eye cataract may take place. So, we need UV protection. So, protection against solar UV radiation, its as far as its behavior, if we see the maximum UV ray is coming to the earth from the sun is in between 10 to 14 hours. So, we must avoid direct sun ray during this time. And also for protection, that environment and legislation changes should be there. So, creation and popularization of global UV index by World Health Organization has been initiated. So, there must be some global UV index should be there, so that people are aware of that change in the environment by provision of shade and other UV radiation protective structure according to UV index. So, UV index is the indicator of presence of UV radiation in a particular place. Depending on the UV index of a particular place, one must know the UV index of that particular place where they are living. He should take precaution by providing shade or providing UV radiation protective structures. And in addition to this shades and structure, we can have personal protection also depending on the UV index value. So, personal protection by using sunscreen, umbrella, hat to prevent ourselves from direct radiation, and also most importantly that we can use UV protective clothing. So, the terms used for labeling are UPF is a very common term. So, ultraviolet protection factor. What is this? It is actually a factor I will discuss. It is to assign the degree of UV radiation protection of fabric. So, this is the factor. So, higher is the UPF value, higher is the level of protection of fabric. So, for fabric we use UPF value. So, if we take inverse of UPF, which is known as EWT, erythema weighted transmittance. So, UPF is the protection which prevent the penetration of the UV ray, and EWT shows the transmission of level of transmission of UV ray, okay. And this also gives the idea about the UV protection of fabric. Apart from UPF, another most commonly used term is SPF, sun protection factor. We normally see in the sunscreen lotion they use the term SPF value. So, mainly used for sunscreen lotions, or sometime for clothing we can use SPF value. And another term which we use very commonly use, that it is a UV index. it is used for daily weather forecasting like temperature, humidity. We can forecast the UV index of particular place, because UV index depend on elevation of a particular place. In addition to that, depending on the type of cloud or type of other environmental factors. So, UV index for a particular place may change depending on the weather condition. Another factor is the eye protection factor EPF, which is used for sunglasses. So, these are the common terms which is related to UV ray protection. First we will discuss what is UPF, ultraviolet protection factor. This is normally we use for our clothing. UPF, it is the ratio of average effective UV radiation transmitted and calculated through the air, and it is taken ratio to the average effective UV radiation transmitted through the fabric. Now, suppose there is UV radiation, we know the energy of UV radiation through air. Suppose it is going x value is through air, there is no obstruction. Same UV ray we are placing on fabric, and fabric will absorb certain energy, so UV radiation, and Y is coming with the fabric. So, UPF, ultraviolet protection factor. So, this x value of x through air, only through air, it will be more than the value, because fabric will absorb little bit. So, UPF is x by y. So, through air, what is the ultraviolet ray is coming to a receiver, and through fabric how much it is coming. The ratio if we take, this is called UPF, which is value is typically more than 1. So, higher the protection of fabric, the value of y will gradually reduce, because x will remain constant, this x value will remain constant. So, a fabric with higher UPF, higher ultraviolet protection, so it will allow less and less transmission. So, y value will reduce. So, if y value reduces, this UPF value will keep on increasing. So, that means for fabric with higher UPF, the UPF value will be more. So, that is why ED is the dose through air and EDF is the effective dose through fabric. So, UPF is ED divided by EDF, which is more than 1, and the reciprocal of this is EWT, okay, that we have already seen. Now, if we see the typical range of UPF, if it is between 40 to 50 or more, the protection level is excellent, okay, and effective the transmission through the fabric will be less than 2.5%. If it is 40, if we calculate, it will be 2.5%, that means 40 times, that means 2.5%. So, UPF rating is 40, 45, 50, 50 plus like this, okay, more than 50. So, only 2.5% radiation is getting transmitted through fabric. Between 25 to 39, it is very good, typically 4.1 to 2.6%, that is the transmission, and 15 to 24 it is a good performance. So, minimum there should be at least 15 UPF value, okay, and the transmission level is typically around 6%, 6 to 7%. So, 15, 20 these are the UPF rating. So, higher the rating better is the protection, and the UPF value we can determine in vitro method. That means, we can use instrument to measure this UPF value. So, where we measure the transmission, the energy without the fabric and take the ratio with fabric. So, we can calculate the UPF value using this formula. Okay. Next is sun protection factor. Okay. So, sun protection factor is defined as the ratio of radiation dose to produce minimal sunburn under fabric covered, it may be fabric covered or may be covered with sunscreen lotion. So, fabric covered skin to the radiation dose to produce the same sunburn of uncovered skin. That it is the actually the ratio of the radiation dose, that is the energy. Okay. Once we cover the fabric, the level of radiation required to have minimum sunburn on our skin, and if we take ratio of the doses without cover, that means MED PS means protected skin. This protection may be by fabric or protection may be by the sunscreen. So, MED/PS means minimum erythemal dose of protection. What does it mean? We need to increase the dose gradually, and that dosing will be around 22 hours, 22 plus minus 2 hours for a certain time. The continuous exposure should be there, and the dose value, that is the energy, we will measure when minimum changes in color, minimum sunburn will be there, that value is recorded, that is called MED/PS. MED/US means minimum erythemal dose of unprotected skin. So, there is no protection, the dose is being applied for same time. In that case, we will see the amount of dose, that is the energy, will be much less than the protected skin to have same level of sunburn. So, MED/US is much less than MED/PS, that is why the ratio is more than 1. This is the sun protection factor, and as in this process we measure the skin burn, the minimum skin burn. So, we require the human as object. So, MED is defined as minimum quantity of radiant energy. Okay. It is actually UVB doses. Okay. This UVB dose is given, which required to produce fast detectable readiness of the skin after 22 plus minus 2 hours of exposure. So, continuously the skin is being exposed, one is with protection, another is without protection, but level of exposure is changed and we measure the level of exposure once the noticeable sunburn is identified, okay. And that ratio is known as the SPF, which is typically more than 1. So, generally used for determination of SPF of sunscreen required human subjects, that is why it is in vivo method based on minimal erythemal doses MED. So, this is the ratio radiation dose to produce just perceptible erythemal under fabric cover. So, this erythema it should be perceptible under cover skin, that is it may be fabric covered skin or may be covered with the sunscreen lotion, and the same is with uncovered skin. So, the ratio is SPF. Next most important parameter, which is UV index. UV index, it is an international standard measurement of the strength of UV radiation from sun at a particular place. So, that is a internationally accepted method where we can measure the strength of UV ray in a particular place. It is designed as an open ended linear scale, that means directly proportional to the intensity of the UV radiation that causes sunburn on human skin. That is, for example, if the light skinned human without sunscreen or suntan begins to sunburn at 30 minutes at UV index of 6. So, UV index, higher UV index means higher intensity. So, at 6 UV index, if he starts sunburn at 30 minutes, then the individual should expect to sunburn in about 15 minutes with double the index. So, in UV index of 12. So, as the UV index increases, the time required for sunburn will be less. So, that is the UV index value, it is typically 1 to 15 is the range. So, 1 to 15 is normal range, and sometime we consider as 11 is the maximum range possible, but for in world few places are there where we can have more than 11 also, which is extreme condition. So, UV index represents the minimum effective readiness received on the skin surface. So, how much radiation we receive, taking into account the cloud condition and other variables of the environment. And if we take the total radiance and then if we multiply by 0.04 to get the value within 1 to 15 range, we multiply it by 0.04 or divide by 25 to get a value within this range. Okay. So, 1 to 2 UV index means it is very weak, 3 to 4 it is moderate, 5 to 6 is a strong, 7 to 8 means it is a very strong, and 9 and above it is extremely strong, where we have to take precaution. Okay. Now, we will discuss how to calculate the UV index value. So, what is UV index we have discussed. Now, try to see how to calculate the UV index in a particular place. When calculating how strong the UV radiation is, scientists only focus on the range of wavelengths between 290 to 400, that is typically between UV A and UV B range, since this range of UV passes through the ozone. Okay. We do not take care other range UV C and UV D, we do not take into account in calculating the UV index, because they are absorbed in ozone layer. So, these are the different wavelengths. This is just one typical example, we can take other wavelengths also. So, wavelength 290 nanometer, 320 nanometer and 400 nanometer has been taken, and their strengths have been specified here. It is actually little bit based on the experience, and here the strength means the amount of UV ray coming into the earth. So, this strength, the longer wavelength UV ray, the more quantity, higher quantity is coming into the earth. So, that means that is why the weightage here it is giving high, and shorter wavelength 290 say weightage is given less. So, strength is 5, because the quantity of UV ray with 290 it is less. So, 5, 25 and 35 the strength is given. So, there are standard methods of calculation. So, from that we can take 5, 25, 35. So, here it has been explained, the shorter wavelengths are absorbed by ozone more than the longer wavelength. So, their strength near the earth surface is weaker. Hypothetical values shown by this earlier table may not be exactly identical to how the different agencies calculate UV index. That earlier table shows some hypothetical values. Different international agencies are there to who calculate the UV index. This hypothetical values may not be exactly identical, but they will be definitely close to that, the trend will be same, but having the strength weighted with a smaller value for shorter wavelength is accurate. That is what I have just mentioned. Now, with the strength, another parameter is weight parameter. So, here we will see the weight value is just reversed to that of strength value. The weight indicates here the effective impact on human body. The short wavelength, although the quantity of ray coming to the earth is less, but its effect on human body it is very high, its impact. That is why it has been weighted with 17, 7 and 2 for 400 nanometer. The scientists found that shorter wavelengths were more dangerous, okay, because shorter wavelength have more energy. So, that is effect on human body is more. To include this information in the calculation, weighting the UV strength at different wavelength is required. So, at different wavelength the weighting was made. This is done using the McKinley erythema action spectrum. So, this is the method. So, weight of wavelengths is in an proportion opposite fashion to that of strength value. Shorter wavelength have higher weight. Okay. That is what I have discussed. Now, we simply multiply the strength with weight. Here we have taken only 3 wavelengths, we can take other wavelengths also. We multiply this strength with weight, and this is the effective result. So, effective result of wavelength 290 nanometer on human body or other environment is 85. So, 320 nanometer it is 175, 400 nanometer it is 70, and if we to simply add all this, so we will get total cumulative effect. So, multiply the strength of UV by weight and the result will be the UV radiation's direct strength at that corresponding wavelength. Continuing with the example, the table given hypothetical weighing factor for the response of skin at UV wavelength, particular wavelength. The strength of UV at each wavelength from 290 to 400 nanometer is then added to get overall impact of UV radiation on human skin. So, we will simply add this. So, total effective UV is 330. So, this is the 330 is the total effective UV. Now, we have to take the consideration of the elevation and the effect of cloud. The elevation means as we go above the earth surface, the impact or energy of UV ray is higher, okay. And at the same time, if the earth surface is covered with cloud, the energy of UV ray reduces proportionally. So, this effect can be incorporated here. Now, account for how cloud and elevation interfere with UV, that we have to take care. So, internationally it has been accepted and it has been determined that for each kilometer above sea level there is a 6% increase in magnitude of UV. So, in calculation we will add 0.06 for every kilometer increase. So, that we have to keep adding. It is also known that UV radiation is absorbed by cloud, which reduces the intensity of UV that hits the earth surface. So, according to EPA, which is Environmental Protection Agency, they have specified that 100% UV transmission is there when there is no cloud, 89% is transmitted when there is a spotty cloud, 73% transmitted broken cloud, and completely overcast sky there is a 31% transmission. So, this transmission level we have to consider based on the type of clouds. So, let us see one scenario. So, we can select one place with an elevation of 5 kilometer from sea level with scattered cloud condition. So, the true effective UV would have to be adjusted 30%, because 6% per kilometer for 5 kilometers, that is 30%, and scattered, that is spotted cloud, it is 89%. So, this two we have to adjust. So, effective calculation will be that effective UV strength will be 330 multiplied by for 30% increase, that is 1.3, and 89% of the transmission due to scattered cloud 0.89. So, it is coming out to be 381.81. Okay. So, considering the elevation and cloud, that is the effective dose, effective strength of the UV, and this now we have to divide the value of UV from the step earlier by 25. So, total value which we are getting, we have to divide by 25, or earlier I have mentioned multiply by 0.04. This is another part of determination accepted by different agency, and then round off to the closest whole number. This 25 is just to get value of range between 0 to 15 throughout the world. So, we can get this value. So, this is the position where it is a maximum value we are getting around 15. So, 381.81 divided by 25, it is 15.27, and its round off we are getting 15. So, we have seen how to calculate the UV index in a particular place, which is very important to select the type of protection we require. So, in the normal, in the sea level, in the ground level which we get the UV, if we go above, say in the hill area, the UV index will be much higher, and there we need more protection. So, increasing risk with the increase in UV value, and the protection we can have different types of protection. So, for 0 to 2 we simply cover head or eyes, but in case where the risk is very high, UV index 11 plus, they suggest do not go out. Okay. So, we have different level of protection measure for different UV index value. These are the standards related to UV protection. So, European standard, Australian and New Zealand standard, AATCC test method for UV UPF test, ASTM test methods. Now, we will discuss the effects of various textile parameters. So, as far as materials are concerned, UPF value changes with the different types of materials. So, UPF of cotton, viscose rayon and linen are usually lower value. So, as far as the materials, so these are the cellulosic material, their UPF values are lower than nylon, wool and silk. Okay. But polyester is found to be having high UPF value. Porosity, weight and thickness, UPF increases with decrease in porosity and increase with increase in fabric weight and thickness. So, thicker fabric or heavier fabric will have higher UPF value, but fabric with higher porosity will have lower UPF value. UPF also increases with the depth of set. So, if we have a material with higher depth, darker shade. So, that will have higher UPF value. If we increase the UV absorber, so UV absorbers, there are different UV absorbers available. So, that will improve the UPF value. Increasing stretch will decrease UPF value, because if we stretch a fabric, that will create larger pores and UV ray will penetrate through that. Okay. UPF decreases with the wetness of fabric. So, when the fabric is wet, the UPF decreases, and for different washing, so UPF was found to be increasing, particularly for cotton. It is nothing but the reason is that here once we wash, the fabric gets shrunk and its compactness increases the UPF value. So, this diagram shows that as the number of cycle of washing, UPF increases. Okay. And fabric geometry, it is a weave, yarn count, thread count, it is a primary factors, okay. And in secondary, which depend on this weave, yarn count, thread density, it is a fabric cover factor, fabric porosity, fabric mass, fabric thickness, fabric mass density, yarn cream. They affect, actually they affect the UPF of fabric. So, if we see the type of fabric fiber here, it is a PET. Due to its conjugated aromatic system, the bond, the UPF value is high for polyester, whereas in case of cellulose this is absent. So, for cellulose UPF value is less, but natural pigments, pectins, wax in the natural cellulosic fibers acts as UV absorbers. So, if we see the UV absorbance characteristics, UPF value for untreated cotton, natural cotton fabric is higher than the washed or bleached or scoured cotton, because during scouring these pigments, pectins or wax they are sometimes removed, wax we remove. The yarn linear density, as the yarn linear density increases, text increases, yarns become coarser, the UPF value increases, keeping all other parameters constant. But if we compare the raw fabric, enzymatically decised fabric and chemically bleached fabric, the raw fabric is having higher UPF because of presence of wax and other material, and this is the same trend here in weft count, in English count, that is weft, as weft become finer, keeping all other parameters constant, UPF value reduces, because the finer yarn produces the open fabric structure and thickness also is less. Peak density, if the fabric becomes more and more compact, that will result higher UPF value. So, that is why the compact fabric is having higher UPF value. Fabric tightness here. So, tighter fabric will have higher UPF value, and this effect is more in case of here it is a satin fabric. Satin has got higher UPF than the plain fabric. Cover factor, with the increase in cover factor, the UPF value increases. As I have mentioned, this will the compact fabric will prevent the UV radiation to pass through, and volume porosity, the porous fabric will allow more and more the UV ray to pass through. That is why the volume porosity, as volume porosity increases, UPF value reduces gradually. And here this curve showing the UV transmission characteristics. So, in x axis it is a fabric mass per unit area. So, as the mass per unit area of fabric is low, there will be high transmission. So, high transmission means lower UPF value. Similarly, for thickness, so lower thickness will have higher transmission value. And this picture shows that effect of color. So, as I have already mentioned, the darker color will have higher UPF value, that means the penetration will be least. So, here we can see in this picture the black has got least transmission throughout the wavelength. So, at different wavelength, if we use a fabric with black color, the UPF value is least there, whereas for natural or white it is highest, UPF value increases, and typically in most of the cases with the increase in wavelength the UPF value transmission is increasing. Okay. So, we have discussed various factors which affect the UPF value. We have also discussed various parameters to define the UV strength, to define the UV rate of UV transmission, or how to characterize the ultraviolet protection factor, and there are different additives which will increase the UPF value. So, these additives are dye, pigments, delustrants, okay, like TiO2, optical brightener, UV absorbers are there. Okay. There are different techniques to incorporate the additives in the fabric structures. So, these absorbers, if we see UV absorber concentration, if we increase the UV absorber concentration in the fabric, the transmittance, the transmission percentage reduces. So, here in this picture it shows UVA transmission 80% of PA plus 20% elastin scoured fabric. So, UVA transmission it is measured here. At the bottom it is showing with a 2% dye stuff, here it is a 0.5% dye stuff, and here it is undyed. So, with the undyed fabric transmission is more, okay, and here with the dyed fabric transmission is least, but as we increase the UV absorber with the 0% dye stuff, although it is a very high, but with the increase in concentration of UV absorber the transmittance reduces gradually. So, the both the dye stuff and the UV absorber, they have impact on transmission percentage of UV radiation. So, we will stop here. We have completed this segment, and in next class we will start another topic. Till then, thank you.